Welcome to our third biology video. Today we're going to be looking at diffusion, concentration, acids, and bases. You should only need to watch this video if you missed something in class or were away. Okay. By the end, you should be able to define diffusion and predict direction of particle movement based on diffusion principles, define concentration, solute, solvent, and solution, explain the relationship between concentration, solute, solvent, and solution, be able to compare and contrast acids and bases, explain how the pH scale works, and finally, identify the standard or healthy pH of certain substances or regions within our body. So let's begin with what is diffusion. A textbook definition would say that diffusion is the movement of particles from areas of higher concentration to areas of lower concentration. And typically, diffusion will continue until a state of equilibrium is reached. In other words, where the two areas are of equal concentration. Sorry, back to my pen. But that brings out the obvious question, what is concentration? Most of us instinctively understand what concentration is, but have a bit of difficulty defining it. So concentration is the amount of solute in a solvent. Of course, that means we need to know what both solute and solvent is. So in terms of biology, the easiest way of defining solute equals the substance being dissolved typically things like salts, sugars, but it can also be gases, and the solvent equals substance doing the dissolving, which in humans most typically water in its liquid form. And when you combine the two together, a solute plus a solvent together gives you a solution. Now to figure out concentration of solution, first of all we need to know that concentration can be abbreviated and will be abbreviated throughout this course using square brackets or square bracket. Concentration can be calculated as your amount of solute divided by your amount of solvent, which is generally measured in grams per liter, or in the human body, sometimes we're talking about much less, milligrams per liter, or in chemistry, we tend to use a more accurate measurement, a term called moles per liter. And if you know what molarity is, great. If not, you don't really need to worry other than to know that if you see something in moles per liter, they're simply talking about concentration. Why is it important to understand diffusion? It's very relevant to our body, and we can brainstorm a few reasons. Draw your little happy self. You might want to add in your phone and your iPod or music. Personally, I'm going to be carrying my little rugby ball. Okay, myself plus diffusion. This can be really relevant on a hot day if you're in a scrum because odors diffuse. So it's relevant for our sense of smell. Okay. Diffusion helps stop our eyes from drying out, so keep eyes moist. Okay. It's relevant. I hate when I'm outside on a nice day and all of a sudden you're choking on someone else's smoke, because that diffuses. Diffusion is critical for nerve impulses. They're functional for, or important for kidney function. Okay. Important for diffusion of alcohol from stomach to blood. It's critical for movement of materials into and out of blood, not just alcohol. It's critical to move O2 and CO2 in tissues and lungs. That's just to name a few. So the concept of diffusion really is going to be important when we're learning biology, and we're going to be talking about it a lot. The most important thing to remember, diffusion is movement equals high concentration to low concentration.